Good morning, everyone. It is 10 o'clock. Welcome to Lighting Design Lab's variable frequency drives. First, I think that we have had, at least since I've been here, and it's been about 12 years. My name is Katie. I'm just going to kind of be in the background and let Diane and Lester run the show. If you've attended any of our webinars before or know the Lighting Design Lab, you know that we are part of Seattle City Light. We're City Light employees, and we are happy to present this broader than lighting information today. And with that, I will turn it over to Diane.
Okay, I'm Diane, I'm the moderator, and I work for DNR International. We're going to be using the questions tab, so if you have a question or just a comment or anything while Lester is teaching, feel free to send it in, and he breaks often to go through anything that you have questions about. And it's about 2 hours, so we'll take a break about an hour in. Leave it to Lester.
Hey, good morning, everyone. Once again, thank you, Diane, for that intro. Today, good morning, everyone. My name is Lester Terrance, and today we will have the course on motors and ASDs, or adjustable speed drives. I will be your instructor today. My name, once again, is Lester Terrance. And a brief background on me before we get started. Diane, I just want to check and make sure, does everything look good on screen?
Yep, you're doing good.
All right, sounds good. Before we get started, I'm just going to give a brief introduction on myself for those of you that have not had the opportunity to take or attend a session where I have been the instructor. But I am a HVAC instructor and instructional designer with DNR International. I started my career as an HVAC technician with the United States Air Force almost 20 years ago. I spent 12 years with the United States Air Force as an airman, performing HVAC installations, maintenance, and repairs. CONUS, meaning here in stateside, and OCONUS overseas. So I have spent a great deal of my career working on different types of HVAC applications, whilst I spent time in the United States Air Force. And from there, I left the Air Force after about 12 years and got an opportunity with the State Department to work as a subject matter expert and field supervisor, supporting United States embassies and consulates globally. So the last 19 years or so, I would say I've spent working on HVAC applications and also training other individuals on HVAC applications as well. This morning, here we have a short course overview, and this morning we are going to focus on AC motors, and the second part of our instruction will focus on ASDs. So what is our focus for today? Day one, we will focus on motors, the wheres and hows of motors, and also the types of motors that are available today in the industry. We'll also cover the anatomy of an AC motor and some other different types of motors. We'll touch on those as we go through the presentation. On day two, we're going to talk a bit more about ASDs, or also referred to as variable speed drives or adjustable speed drives. And we'll talk to why those speed drives are valuable. We'll dive in a bit on the evolution of ASDs, and then we'll talk about how ASDs works and the different segments that ASDs need to go through in order to operate the right way. And then we'll also touch on a few energy savings case studies. So once again, on day one, which is today, We'll cover motors, so you'll have a basic understanding of the characteristics, functions, controls, and types of motors for common commercial and residential applications. And on day 2, we're going to dive a bit deeper and talk about ASDs or VFDs, also known as adjustable speed drives and variable speed drives, where at the end of that, you'll be able to describe the relationship between VFDs and motors and the benefits of incorporating VFD or ASD systems into your applications. Today, we'll be utilizing Slido for our activities that are part of our presentation today. Slido is free, it's anonymous, it doesn't require any registration, and it does not track your information. So for those of us that are worried about that, Slido will not be tracking any information that you have. It's just an application that we utilize to have the activity portion of our presentation today, where it performs that as a poll. You can use your web browser, your smartphone, tablet, anything that you have available to you to participate in the activity portions using Slido.com. Now, there are 2 different ways that you can access Slido. You can scan the QR code or go to Slido.com and join the event with the code MOTORS. Once again, that event code is MOTORS. You'll enter that at Slido.com, and that will give you access to our activity sessions or any polls that we'll be taking during our presentation. It's an important part of how we interact with one another through this digital platform. And the more participation we get, the better that this presentation will be. So in order to verify and make sure that Slido is operational and everyone has got the hang of it that is in attendance today, we have a short introduction survey here. So what we're going to do is we're going to give some time here for our attendees to go ahead and answer some of these questions in our introductory survey, and then we'll go over that once you get done. So we'll take about 5 minutes here to go through this introduction survey. If you are taking part in that, you will go ahead. There's a QR code at the top left-hand corner of the screen. You can utilize your mobile phone to scan that QR code, which will take you straight to Slido.com. Or you could join us at Slido.com and utilize the keyword motors, which will give you access to the Slido poll. So we'll wait for a few of our attendees to get access into Slido just to make sure everything is working, answer the introductory survey, and then from there we'll do a brief review on what everyone was able to do. If you're having any issues with Slido this morning, please let us know in the chat area, chat function, and we will look into what issues there may be having. So let's take 5, and we'll come back here shortly once everyone has jumped into the Slido broadcast and are able to take part. Any issues, please let us know in the chat area. For those of you that may have just joined us, we are taking an introductory survey, and we are using Slido.com to do so. So if you can join us at Slido.com, you can utilize your mobile phone or browser, and the keyword will be motors, or you can scan the QR code at the top left-hand corner of the screen. Give it about another minute. Looks like we still have some individuals jumping into the Slido active poll. Once again, we're using Slido today and for the presentation today and on Thursday for our activity sessions. You can go to slido.com, keyword is motors, or you can utilize the QR code at the top left-hand corner of the screen.
We have 10 attendees.
Thank you. All right, let's jump into it. For those of you that are still going through the introduction, please feel free to continue that. We will continue moving forward here. All right, so first question on our active poll is, how are you doing today? How's everything going? And for the most part, we've got everyone doing pretty good, amazing, here to learn. And we've got some other individuals saying, let's get things going. So we will do so here shortly. Tell me a little bit more about yourself. What do you do and how long have you been doing it? Here we have Idaho Power Electric Utility Energy Advisor for the last 6 years. assisting with energy efficiency incentives with commercial customers to include motors. Still learning and relearning about motors, ASDs, and their impact on customer usage in our distribution system. Awesome to have you. Energy efficiency fellow at healthcare firm, wanting to learn more about discrete technologies I can employ to help, lead GA and BOC level 1. Electrical design, 2 years. I am an instructional design professional and has been in education for 15 years. All right, so it looks like we have a wide range of different backgrounds here. And once again, today's course is on motors and ASDs, very general course, overview on the two different components or applications. And we'll definitely dive in on each one of those and talk more to how they work and how they function, and a little bit more about each. Where would you rate your current understanding of motors and adjustable speed drives? So it looks like a good majority of our class is just here to learn, here to get it all. So we will be doing that Tuesday today and on Thursday. Like I said earlier, we're going to go ahead and dive into motors today. And then on Thursday, we're going to touch a bit more on our adjustable speed drives, variable speed drive components. Got about 25% of the class got a handle on ASDs, still working on motors. No worries. Today, like I said, we're going to dive into both, and we'll give a bit more in-depth instruction on both of those items. So the wheres and hows of motors is what we're going to tackle here next. And before we do that, we want to think about motors. Before we dive into motors, we want to think about what are motors. How do we define motors? And you can see here on our screen we have a definition of what motors are. But motors are rotating devices which converts electrical energy into mechanical energy. And they're typically used in a lot of items day to day that we use commonly. But some of the applications that you may find motors in are electric fans, refrigerators, washing machines, mixers, HVAC systems, and some other applications as well. So motors are a big part of our everyday lives. And some of us may not even realize that, but today we're going to show exactly how that's possible. So here we have a short clip. I just want you to take a look at this clip here. Let me make sure that all my audio is working okay. Give me one sec. Hey Diane, can you let me know if you can hear this video playing?
No, I can't.
Okay, what I'm gonna do is, if you don't mind, Diane, if you can place the link for this specific video in the chat. I'm having an issue with GoToWebinar and playing that audio.
Okay.
So what we're gonna do is, because I cannot get the audio in this clip that we have here, Diane is gonna place the link for this clip in the chat area, and we'll take about 5 minutes to watch that clip. And following that, we're gonna talk a bit more into what are the everyday uses of motors. So once you get done watching that short clip, it's about right under 3 minutes. We're gonna go ahead and type in some different types in the chat area. I'd like for everyone to type in some different applications or different things that, after watching this video, different things that you find in everyday situations that utilize motors, that you could think of. So, for instance, this morning, I actually thought about it. I woke up and I have an electric toothbrush, and I was curious to find out what type of motor was in that electric toothbrush. And I was able to find out that it is a vibrating motor, but we'll dive more into that. So after you completely watch this small clip here, what I'd like for everyone to do is, in the chat area, just list a few different examples of where you may find motors that, from waking up first thing in the morning all the way till you're just about to go to bed, where can you find motors in different applications?
Feel free to let me know in the questions area if you cannot get it's a YouTube video, if you can't get it to launch. I think it should be good to go though.
I'm gonna go ahead and try it out, Diane, just to make sure.
It works on my end.
Okay.
Great. Somebody got
All
it.
right. Awesome.
Katie got it.
Yeah, so we'll take a few minutes here to go through that video, and then we will, once you get done in the questions or the chat area, just go ahead and list a few different areas where you think you may find motors, or you know you'll find motors that are used every day. Looks like we got some attendees now starting to put in some information here in the chat. So we'll give it about another minute or two for those of you still watching the small clip. And once again, if you don't mind posting in the chat area, where in your day-to-day lives may you find motors, or may you find motors that you're using to accomplish some sort of a task. So far we have in the chat that refrigerator is one place that you will find a motor, and that is correct. So we're looking for a few more, and then we'll move on.
We have in the questions area, washing laundry this morning, both washer and dryer, opening windows on my truck, window motors, the vehicle engine, and another person said car.
All right, yeah, all of those are good good applications, and are applications that utilize motors. So it looks like everyone is on point here. Okay. So without taking any more time here on this section, we're going to continue moving forward. I thank everyone that has placed any of the requested information in the chat field. Thank you for that. So motors are part of our everyday lives. And from the moment we wake up in the mornings to the time we close our eyes to go to bed, a motor is performing some function for us even whilst we sleep. And one example of that is HVAC applications. So if you have a home residential AC system, um, there is a motor in your inside and outside unit that is running even when you're not home, or even whilst you're sleeping. And that system is running in order to keep your home either cool or hot. But for the most part, AC motors are the workhorse industry standard, and they are responsible for work that is being performed in several different applications. A motor, and for some examples that we can talk to is uh, taking a shower in the morning. When you take a shower and you want hot water, a motor or some sort of a pump moves the water to your faucet so you can take a shower. Motors spin the table inside of your microwave when you make breakfast. So we see a microwave here. The spinning function that's happening in your microwave as that dish is rotating to get hot, there's a motor inside of that microwave that is creating that action. You have motors on your garage doors, and you also have motors in your cars. Uh, so motors plays a critical role in our everyday lives. And without motors, things may be a little bit more difficult to perform. Or can you imagine if we took away motors, period? A lot of things that we do on a day-to-day basis will have to be done manually. And some of the comforts that we have will be taken away as well. So if you can look to the lower right-hand corner, you can see a picture of a Tempur-Pedic. I recently bought one of these beds, and I got it with the adjustable base, and it's actually a pretty awesome bed. If you get it with the adjustable base, and the adjustable base that's on one of these Tempur-Pedics operates by the use of a motor. So we can see several other different components and applications here, such as hair dryers and laptop computers, and also fans. And someone said refrigerator earlier in our chat. So we have several different applications that utilize motors on a day-to-day basis, and they are the workhorse industry standard. So with that being said, here are some applications of motors in building systems. So from left to right, we can see we have a cooling tower, an air handling unit, and also a pump. Now, cooling tower motors are pretty much designed for high humidity environments. And these cooling towers assist in cooling the condenser water coming back in a chilled water system. So you'll find motors in cooling towers that are used in chill water systems to cool down that condenser water that's returning from the loop. Another favorite place of mine where motors are located are air handling units. And air handling units are systems that are part of chilled water systems. Air handling units contain motors for airflow. So you'll find those motors in there for the supply and the return of that airflow in specific instances. The size of the motor in itself depends on the size and requirements of that air handler. So whatever your application is when dealing with the air handling system, as far as the square footage of your facility or your site, all of that is going to be dependent upon the end motor size and what type of motor you're going to be utilizing in that air handler system. And then finally, to the right, we have our pump. And pumps are generally powered by electric motors. A lot of the time you will find chill water supply and return pumps will contain a motor on its pump system. And in the industry, you will find a lot of these motors that are attached to these pumping systems. You'll find that within any type of pump type application that you have, it's going to have a motor attached to it. So you won't find the pump just by itself performing work. There is a motor attached to that pumping system. Let me see if I could get my, here we go. So if you can see my marker here, to the right, over on this side, we have our motor. This is our pump. Entire system, will call it our pump. But to the right is our motor over here. And this right here, the small portion of the pumping system right here, is the actual pump. Okay, so most pumping systems that you're going to find has a motor attached to a pump, which performs work and allows that that pumping system to deliver whatever it is that it is designed to deliver. So, for instance, we spoke about taking hot showers in the morning. You may find a pump similar to this one containing a motor which will pump the hot water. If you live on the 15th floor of an apartment building, that pump is going to be able to supply that hot water and pump it up to the 15th floor. So that way you can get the hot water you require to take your shower or wash dishes or whatever else it is you're doing with that water. So these here are just a few applications of motors in building systems. Here we have some more applications of motors in building systems, and from the left to the right, we have boiler systems, AC split systems, and also exhaust fans. In our boilers contain motors at the combustion chamber or the combustion box. Let me get my mouse here so you can see exactly where that's located. So our combustion chamber, where we have our initial flame light off, is going to be right up here. Okay. And right here, you see this blue component. This is your motor. And your motor is what's drawing air into this combustion chamber box in order to create combustion, so that way we have the boiler here working for whatever is required of it, whether it's domestic hot water or heat. Once again, that motor that's attached to our boiler system, it's used to draw in air into that chamber to ignite the flame used to create heat or steam within that boiler system. Directly next door, we have an AC split system where you have an inside unit and an outside unit. And the split AC system uses motors in both the inside and outside unit, or in this case, we're going to call it the condenser right here, and then our indoor blower motor. So in our indoor blower motor, which this is the component that sits inside of your space, whether that be your living room, your office, wherever you have it set up, this unit here will contain a motor which is going to blow that cold air into the space. And the condensing system, or the outside unit, is also going to contain a motor, where that motor is rejecting the heat taken from the interior, or that space, and put it out into the ambient air. So in our AC split systems, and these are pretty common to some residential applications, but mostly small office applications, but you can definitely use these in residential applications. You'll find that motors are contained in both the inside and outside unit. And then lastly, to the very right, we have our exhaust fans. And exhaust fans are great for removing heat or gases from a space, and it's by the use of electrical motors. You can find them in bathrooms, generator rooms, and any area requiring the rejection of air within a space due to that application specific use. So I do know in battery rooms, for example, you'll find exhaust fans, and they're there to relieve the battery room of certain gases that may start to accumulate in that space. And those gases do need to be rejected to the ambient air, just so we don't have any types of arcing or explosions, which we will talk a little bit more about types of electrical motor encasements. And there are a few different types, which explosion proof is one of them. So we will cover that at some point during our presentation today. And lastly, it's not pictured here, but chilled water systems. Motors are used in chilled water systems, and we did cover that briefly, but in both pumps and the air handler unit. And then we just have a few more to cover as far as motors in building systems. And you'll find from left to right a few more systems that you will definitely find motor or electrical motors present in. Compressed air systems is one of those applications. And compressed air systems utilize electric motors to power the compressors of those systems. So we can see a trend here with motors. Their use is typically to either power another component, um, or it's part of some sort of application. Okay. Motor sizes varies as the compressor and the unit size increases. So in your compressed air systems, if you have motors which are not motors, but if you have compressed air systems which require larger capacities, then your motor size is also going to change or increase depending on what that capacity is. Directly next door, we have our air-cooled chillers. These are some of my favorite systems, just because of how easy they are to work on and maintain. But air-cooled chiller systems utilize condenser fan motors to reject the heat load absorbed from the facility. So similar to our split air conditioning systems, you'll find that on this specific air-cooled chiller, all the components are right there within that air-cooled chiller. And one of those components which utilizes electrical motors are the condenser fan motors that you can see at the very top. These air-cooled chillers, you'll typically find several condenser fan motors at the top. As you can see on this one here in our example, we've got 10 condenser fan motors within this air-cooled chiller system. So that's 10 motors that requires maintenance and or may require a replacement if it becomes faulty at some point or another. I've been to some of these units, and on extremely hot days, you may find a few of these different condenser fan motors not working. And that is going to be a long day because all of those motors need to be replaced so that each circuit within this air-cooled chiller operates to maximum efficiency. And then over to the far right, we have the rooftop units, or RTUs, which are typically utilized in medium to large commercial sized applications. The commercial rooftop unit does contain several fans, similar to the air-cooled chiller, but everything to include the air handler, for the most part, is packaged in a commercial RTU or rooftop unit. So you'll also find the condenser fan motors and the evaporator fan blower, all compartmentalized inside of that rooftop unit. And it's actually a pretty good design, where everything is located in one spot and you can perform all your maintenance and diagnosis without going to too many different areas. So you have several motors that are in your rooftop unit. You have several motors that are in your air-cooled chillers, and that's just one component. One component. And remember that I stated earlier that the AC induction motor is the workhorse of the industry. And we'll go into that here on this next slide to talk a little bit more about the use of motors in the different industries that we have out today. So this next slide here is covering the energy use of motors in the U.S. And this is just some data that shows that motors pretty much use a lot of energy. Many of these motors run 24/7 over the course of their typical 20-year lifespan, and that's whether it's a motor used in a residential application, a commercial, or an industrial application. Those kilowatt hours do add up. So when when you are thinking about motor use and purchasing motors, you want to keep all that information in mind, um, where you pick up the most efficient motor for your application, and typically that may end up being a little more pricey, but it'll save you a lot of money in the long run. And we'll cover some of that later on in our course. So here we have three different sectors in the U.S. that utilizes motors for their day-to-day application. And we'll start over here in the residential sector, where you can see a good deal of the motor use is being utilized for space heating, space cooling, and also water heating. And we have a small amount for refrigerators and freezers. So if we take that right down the middle, it's almost about half. Okay, so almost 50% of motor use in the residential sector um, is being utilized by motors through the use of space heating, space cooling, water heating, and also refrigerators and freezers. Now, if we go over to our commercial sector, we can see that some of our motor use is about right down here, where you can see refrigeration, space cooling, and ventilation. To include, well, space cooling would be for your office areas, but when we speak more to that yellow section, computers and office equipment, you have smaller motors inside these applications that does the work that it allows these computers and office equipment to do. But for the most part, when we're thinking about it, we can see here that refrigerators, space cooling, and also ventilation plays a big chunk of the commercial sector's use of motors. So we want to keep that in mind. And lastly, U.S. manufacturing and its motor usage. We can see that machine drive, 50%, almost a little over 50%, right down the middle, is the biggest use of motors in the manufacturing industry. So when you think about the manufacturing industry, think about the use of robotics for the most part. Today, a lot of robotics utilizing motors is responsible for the manufacturing of several different goods that we utilize today in the U.S. So motors are used to manufacture with other applications. So what we want to keep in mind is that across the board, motors are typically responsible for most of the work and most of the applications that we are using on a day-to-day basis, whether that's in the residential sector, commercial sector, or even in the industrial manufacturing sector. Motors play a huge role on a day-to-day basis, sometimes running over 24 hours a day, 7 days a week. And that ultimately will bring up your kW use as far as kilowatt hours and energy use at your facility or site. So you definitely want to pay attention to that. So that way, when you are making upgrades or looking to save on your energy bills, you can start to see what parts of your site is using the most kilowatt hours, and then look to try to either upgrade that motor or see what's going on with it in order to save. So as we just covered in the different industries from residential all the way to manufacturing, motors utilize a lot of energy, a lot of energy. Um, and a great deal of the time, the amount of money that you're spending on these motors, um, the maintenance, operating costs, and owning costs will typically outweigh the initial purchase price. So if you look at what we have on screen here, our slide on screen, it shows that the average electric motor lasts about 20 years, and that's about right at about average. I've seen some motors that's been installed in systems almost 25, some 30 years. And the reason that they were able to be there so long was because the maintenance was great over its lifespan. But if you look here, you can see that 1% of the total cost of an electric motor is in the initial cost, initial purchase cost. So that is a small amount. So once you purchase that motor, let's say you pick up a motor for a pumping system for about $450, it'll probably cost you more to maintain, or not probably, but it will cost you more to maintain, run, and also own that motor than the initial purchase price. So uh, what we found out about this is that most of the cost of motors is not in their actual cost, it's in the cost of operation and maintenance. And because motors run most hours of the day and most days of the week, they consume a lot of kW's worth of energy. It pays to spend a little bit more on the actual cost of the motor because the savings over 20 years of operation will be significant. So what that means is that today we have motors, they're a bit more expensive, but they do save on energy costs due to the components that those motors are built with and the energy savings that they offer. So let's talk about a few different types of motors. But before we get into diving into these different types of motors, we're going to take a quick electricity survey. And this survey, all it does for me is pretty much lets me know where our class is as far as knowledge level when it comes to electrical principles. So before we move forward, let's take a quick break here to look at this Slido activity. And once again, for those of you that joined the course late, up at the top left-hand corner of the screen, you'll find a QR code. which if you scan that with your mobile device, you'll be able to access this activity at slido.com. And if you're not using the QR code, you can also go to slido.com and enter the keyword motors, which will give you access into the poll. So we'll take about 3 to 5 minutes here just to go through the Slido poll, and I will review once everyone is done. If anyone's having issues with the Slido application, please let us know in the questions or chat area, so that way we may be able to address it. We'll give another minute or so here on the activity session, and we will move forward. All right. What we're going to do now is go over this survey. And for those of you still working on it, please continue. Once we get done, we're going to take a short 5-minute break, and we'll come back and continue the rest of our presentation. Now let's get into this survey. So, when was the last time you studied physics, electricity, and/or electrical principles? We have roughly half the class, a little under half, at 1 year ago, 40% at 2 to 3 years ago, and Another 20% at about 5 years ago. Okay. When thinking about electricity, identify your level of understanding. And we have, looks like a good deal of the individuals who has answered. I understand and can identify the major themes. I'm ready to start my learning journey at 0, and the other answer at level 3 is at 0. Tell me one thing you know about electricity or electrical principles. Electricity parameters are volt, ampere, and ohm. Inducing a current through a magnetic force. Direct current was the first kind of current used to power buildings in the 1800s. All right, so it looks like we have a decent amount of knowledge on electrical principles and practices. So we should be okay and good to go for the next up and coming portion of our presentation. But before we move forward, what I'd like to do is take a quick 5-minute break. We do have a great deal of material to still cover. Excuse me. So we'll go ahead and break now for 5 minutes, and we will come back once that 5 minutes is over and talk about where our power comes from. So let's go ahead and take 5, and we'll come briefly back, take a stretch, grab some coffee, and we'll continue our presentation here shortly. All right, hopefully everyone had a good break. We're going to go ahead and get started again. And now we're going to talk about where does our power come from. So we do have an image up here on the screen, and you can see a generating plant. And starting at that generating plant, at the very end, we have our industrial customers and our residential customers. And it's important to know a little bit about electricity when learning about motors, because the different motor designs are dependent upon different types of current. Power doesn't just appear at an outlet. Your energy that you receive at your residential location or commercial location undergoes a pretty complicated journey from generation to distribution. And this specific graphic here illustrates that journey of electricity from generation all the way to its consumers or customers. Now, power generation ranges in different situations and regions. So if we're looking over at our generating plant, typically power generated can range anywhere from 4 kW or kilowatts, kilowatt hours or kilowatts, all the way up to 34 kVA. I'm sorry, I said kilowatts before. I meant kilovolts, kVs, not kWs. So there is a difference. And I know most of you in here know that. But your power generation can range anywhere from 4 kVs all the way up to 34 kVs. And that's just power generation coming from the plant. Okay. It's then stepped up to typically a few 100,000 volts for distribution to the substations. And that's dependent upon, once again, your region, how big or small your town is, where that power is being generated. It could be a lot lower, it could be a lot more. And it just depends upon where you reside, how much power is generated and stepped up to be distributed to your substations. So once you generate that power, it's sent to a step-up transformer where it is the voltage is stepped up to a few thousand volts, 100,000 volts for distribution. And it could be less, like I said, and that depends upon your region or where you're living. And that power is transmitted across high voltage transmission lines. Okay. From there, that power is going to reach your substation, which has a step-down transformer. And that step-down transformer is where you're going to get your 415 volt power out to your commercial or industrial users. And then you'll have your 240 volt 120 over to your power for residential consumers or customers. So your electricity from generation all the way up till it reaches you at your home or your business goes through a pretty lengthy process before it gets there. Really quickly, some key takeaways we just want to mention about the electricity that's being transmitted. Under voltage in any system hinders the performance and also its reliability. So we want to make sure that we have the correct voltage going to all of our applications. Over voltage destroys the insulation and windings and destroys bearings on a motor. It does not result in any higher output or better efficiency. So applying more electricity to your motor systems, and if that motor system is not designed for it, will definitely destroy that motor system, and then you will have to replace it because it will destroy the internal windings on that motor. Electric motors are designed to operate within plus or minus 10% of its rated voltage. Continuous operation or poor incoming voltage will definitely shorten the motor life. So these are just some key takeaways you want to remember when thinking about electricity and power. And that way that can assist you in understanding exactly where your motor systems need to be voltage wise within the commercial industry or your residential applications. Now we will jump into alternating versus direct current. And electrical current pretty much comes in two types. We have direct and alternating. Direct current flows only in one direction. Most of our electronics and appliances require current to run, but direct current is difficult to transmit and hard to adjust. So we utilize alternating current, AC current, and that AC current doesn't go in one direction, it switches directions. AC current is the type of current transmitted from the generation plants to our consumers or customers. So in our previous image, you've seen that the generation plant at the very left, and then you've seen your consumers at the end. Your AC alternating current is what is being generated at your plants. So it's easier to transport and adjust your AC current with the use of transformers, which is called stepping up or stepping down. So just to keep in mind, your direct current, when you think about it, think about the image that we've seen, not the image that we've seen before, but when you think about direct current, think about what you're seeing here in this image, which are batteries. Any type of stored power will be dependent upon direct current. And your AC current or alternating current is the current that's going to be generated at your electricity generating plants and go along that process of stepping up and stepping down in order to create the correct electrical source of energy that's required for residential or commercial applications. So once again, you have two different types of electricity. You have direct and alternating current. One moves in one direction, which is DC, the current only flows in one direction, and your AC current flows, it actually switches directions, but it flows in two different directions. So you can see that here in this this image where you have AC current moving back and forth. The flow of electrons are moving back and forth in this image here. And in the direct current, you can see that your flow of electricity is moving in one direction. It's not going back and forth or reversing and turning around. It's only going in one direction. So when you're thinking about alternating current, think about that current moving in different directions. And when you think about direct current, think of that current moving only in one direction. We'll talk a little bit about single phase versus three-phase power in AC systems. And current can be expressed graphically as well. Direct current, as we just spoke about on our previous slide, only flows in one direction and does not change. Now, this graph that we're looking at to the far left shows a straight line that represents direct current or DC current. Now, remember that our alternating current changes direction. So this graph in the middle shows a sinusoidal wave that is used to represent our alternating current or AC current on a single phase application. It switches between positive and negative voltage, just like alternating current switches direction. Finally, the graph on the far right shows the alternating current of three-phase power. It's called three-phase power because there are three alternating current lines offset by 120 degrees. A typical electrical pole has three wires for the transmission of each phase of current. So where you'd find in a single phase application is you typically find your your single phase of electricity coming in and some sort of a neutral. On your three-phase applications, you're going to find three legs, as it's called in the field, or three phases of power coming in to your application. And here we have some of our different types of motors when talking to DC motors and AC motors. And it's important to know a little background about electricity, because different types of motors rely on different types of electricity or current. In general, we can organize motor types in these two groups here, where we have DC motors and AC motors. DC motors use direct current, whilst AC motors uses alternating current. Within these two groups, there are different motor designs, but for the purposes of this class, we'll be focusing on brush DC motors and induction AC motors. So let's take a look at our DC motor. These motors use direct current and are great for smaller applications and electronics. Drones and RC vehicles often utilize DC motors. Another place that you might find DC motors, and I think I said this earlier today, was in an electrical or electronic toothbrush. Those toothbrushes either contain a vibrating motor or some sort of brushless DC motor. DC motors, once again, they operate by direct current. DC motors take electrical power through direct current and converts this energy into some sort of mechanical rotation. And they're typically found, once again, in smaller applications, anything you can radio control, such as RC cars, drones, electronics, and some appliances. The voltage typically ranges from 1 to 1.5 volts to 100 volts or more, and smaller, more for precision controlling, for example, the arms of surgical robots and such. So those are your DC type motors. And your AC motors, your AC induction motors, these motors use alternating current and come in two distinct varieties, which we covered earlier, our single phase and three phase applications. Just as the name implies, AC motors uses single phase current, while three phase AC motors uses three phase current. AC motors are often used in large applications, especially in building systems and industry. Most of our HVAC systems rely pretty heavily on AC motors. So the HVAC industry is really big on utilizing AC induction type motors, and you find them, like we explained earlier, in our air handlers, in our chillers, in our split AC systems, in our boilers, and also our exhaust fans. So that's just one industry, one small industry of where motors are heavily used. Now, over here, we're going to talk a bit on this slide about single versus three-phase systems, or single versus three-phase motors. Single-phase motors, like we spoke about earlier, uses that single-phase alternating current. They are typically smaller and require a lower voltage to operate. Our three-phase motors uses three-phase power, and these motors are typically larger and require much higher voltages. So a quick example of where you might find a single phase and a three phase, if we're going to talk to air conditioning applications, is that on our residential systems, we're going to have single phase AC induction motors on our split systems. So you'll have that on your interior system and your exterior system, and those motors are typically single phase and rated for 220 applications. Your three-phase motors, you'll more so find those on a good example would be a chilled water supply pump on a chilled water system. Here you will probably have a motor which contains three phases, and your voltage source will probably be somewhere around 415 volts. So types of AC motors, the application is important when selecting AC motors. Motor sizing is an important part of the process in selecting a motor. More of your single phase motors, like I mentioned earlier, in residential applications, the voltage are going to range up to 120, 240, and there's a common and neutral, and you're hot in the electrical wiring that's coming in. So the power is pretty much capped to these systems. So your hair dryer can work in a traditional outlet when you plug it in. That's about 120 volts. Your three-phase motor systems, which are more geared to commercial power, your voltage ranges are from 240 to 460. There are three phases across this electrical connection we covered earlier, and this is to provide more power for larger applications. So your RTU systems, for example, are probably going to be, your rooftop units are probably going to be on a three-phase system. Now, some key takeaways really quickly for your single phase and three phase motors. Your single phase motors run off single phase power supply made up of a 2-wire circuit, contains 2 windings, your main and your auxiliary start, and your electricity or voltage values are between 115 or 230 volts, depending on your application. So your AC system in a residential setting would be on the higher end at about 230, and your other applications such as a hair dryer, your TV, your computer systems, those are going to be on the lower end at about 115 volts. It's typically used in homes and offices where single phase power is supplied from the utility pole. These motors are not self-starting, and often you'll find that they require a capacitor. The capacitor uses auxiliary windings to generate the rotating magnetic field within those motors. Other single phase motors include split phase induction motors, capacitor start, capacitor run induction motors, and also shade pole induction motors. And then we have our three-phase takeaways, takeaways from three-phase motor systems. Three-phase motors have 3 windings. One thing that you'll find on a three-phase motor that you won't find, one thing that you find on a single-phase motor that you won't find on a three-phase motor is a capacitor. No capacitor is required for three-phase connections. Your three-phase motors also utilize 2 types of connections. I'm just throwing this information in here for those of you that want to review it later. It's a little bit more in depth, but it is important to understand. And once you get a copy of the slide deck, this information is in the instructor notes for your review. Your three-phase motors uses 2 types of connections, and those 2 types of connections are delta and your Y connections. Now, your delta connection is a 3-wire circuit used in a 3-phase electrical system, and it's formed by connecting one end of the winding to the starting end of another winding. The connections are continued until a closed loop is formed, and it represents, not represents, but it resembles a triangle once it's completed, and there is no neutral cable. This is all for your delta connections in a 3-phase motor system. Your Y connection, on the other hand, is a 4-wire circuit used in a 3-phase electrical system. All 3 windings are connected to one single neutral point. The connection resembles a Y, and it's sometimes referred to or called the star connection. And just some major differences between your delta and your Y connections. The delta winding configuration is better for motors that start under load, but they draw more current. So if you have a motor system that draws more current, you want to have that that motor system wired up in a delta style. Your Y configurations consume less energy, but typically don't produce the torque needed to start up under a heavy load. The star uses less voltage and less current than the delta connection. So the star or Y connection uses less voltage and less current than your delta connection. So those are just the types of connections electrically that you can make within your three-phase motor systems. And those connections are either a delta connection or a Y connection. Here we have single versus three-phase applications, the types of applications that you may find between the two different types. Single-phase AC motors are great for smaller applications, like HVAC systems found in homes and also small offices. Our three-phase AC motors are better suited for medium to large applications. They work best in building systems like commercial RTUs or air handler units, but you also find them running pumps at aquariums, moving water in wastewater treatment plants, and powering compressed air systems. So your single-phase residential motors, typically used in homes and offices where single-phase power is supplied from utility poles. These motors, once again, are not self-starting, requires a capacitor because it is single phase, and the voltages range up to 240 volts. Our three-phase motor system on commercial, providing more power to larger applications. They're self-starting and you can utilize them on RTU systems or any larger commercial type systems that requires more power to operate. So a really quick review. It's important to know a little background on the electricity as we covered earlier, and even uh, look to see how far back some of us have taken any types of electrical courses or math related courses, so that way we can understand more about why electricity plays a really big role in the performance of motors. Um, and we did cover the different types of motors that are out there between DC motors and AC motors. And we spoke to how these different motors operate and their properties as far as voltage capacity within both systems. So really quickly, we understand DC motors use direct current, whilst AC motors uses alternating current. And our DC motors typically are used in smaller applications. And our induction AC motors, which comes in two different types, are single phase and three phase, where our single phase AC motors work very well for residential and smaller commercial applications. And our three phase AC motors are typically and often found in medium to large commercial applications, especially in RTUs and air handler units. Now, there are other types of motors out there, but the brushed DC and the induction AC motors are the most common types that you will find in the industry today. Now, we did take a break, so we're going to go ahead and skip this break here and push through to the end of our presentation. I believe here we do have a short activity that we're going to take an opportunity here to knock out. So the task here is to select an article and explore it, and then come back and share two of the things that you've learned in that article. Okay, so there's going to be, I think, 2 to 3 articles that are going to be available in the chat. and you're going to select one of those articles to explore more, either about brush DC motors and induction motors, or you could select the other motor type article, which talks about other motors that you may encounter in the field. So let's take about, time is it 14:27? Let's take about seven minutes here to explore the articles of your choosing. And at the end of that reading, I will have it up on the screen here shortly, but you have another Slido application where interaction, I'm sorry, where you go ahead and answer some questions, come back and pretty much tell us about some of what you have you've learned from those articles about those motor types.
Lester, I see 6 links.
So let's go with the top. Let's go with the
Because there's 3 of them are YouTubes.
One is the article, a good guide. Yeah. So let's go with all the way up to what's the difference between AC/DC and EC motors. So that's the last link. And I think that what's the difference should be a PDF.
You want all 5 of them?
Yes, that way they have our attendees have the option of selecting which one they'd like to view. So I think 1, 2, 3, three of those different types of media are going to be YouTube videos, and then there are 2 of them that will be articles. So a good guide to types of electric motors and what's the difference between AC, DC, and EC motors. So let's go ahead and select, you could select 1, you could select 2 to look at, but let's take about 7 minutes here to go through, 5 to 7 minutes to actually watch these videos and go through them or read the article. And what we'll do from there is select 2 things that you've learned about the motor type you selected. Once again, we'll use slido.com for this active poll. There is a QR code on the top left-hand corner of the screen, and the keyword to enter that active poll is going to be motors. All right, looks like we have some individuals already in the Slido activity session. So take another minute or two to get our answers in there, and then we're going to go over them shortly. All right, let's jump into our active poll. If you're still working on that, please continue. Looks like we have 2 answers in here. Switched reluctance motor was one someone selected, and they have here that it uses electromagnets to apply field to rotate motor using precise timing to turn efficiently. If replaced, every motor with this type of technology reduces emissions by 25% globally. And then we have EC motors. They are DC motors that have an external electronic controller that converts AC supply to DC. Used for lower applications like servo motors, though advances have made them available for large usage up to 12 kW currently. Runs 30% more efficient as copper heat loss is reduced by around 50%. For those of you that participated in that activity, I just want to thank you. And great answers on each one of those, by the way. EC motors are the future of our industrial side if we can get a lot more of those motors into different applications. So let's pause here really quickly for any questions that may have generated in the chat. Diane, do we have any questions currently at this time?
We do not.
All right, let's keep pressing forward. Got about 20 minutes left in the presentation. So anatomy of an AC induction motor is what we're going to touch on next. And here we have an image of an AC induction motor. So get my highlighter out here. So we're going to dissect an AC induction motor to learn more about its important components. All motors are made up of a rotor, stator, fan, housing, and they also have a nameplate. We do know that an electric motor is a device used for converting electrical power into mechanical power. Electrical motors generate the magnetic field with electric current through a coil. The magnetic field then causes a force with a magnet that causes movement or spinning, which runs the motor in part. Some of the main parts of this induction motor here, we'll start with the stator and the rotor. But our stator is a stationary part of the motor where the windings are housed. So our stator is going to be right here, right in here. Okay, this is going to be our stator, and our rotor is the moving part of the electrical motor. So our rotor is going to be located in here. It's the shaft that's sitting in here. This is the rotor. Our bearings are designed to support the rotor and maintain the correct positioning of the shaft. So right in here, you're going to find the bearings to the motor. And then you have a fan back here, which cools the motor during its operation. It's connected to the opposite end of the shaft. So when the rotor is spinning, the shaft is turning that fan as well, which will be able to cool that motor down. And then up here, you have your motor terminal housing, and that housing keeps all your electrical wiring, which connects the power to the motor. And then lastly, you have a nameplate which declares motor information such as your voltages, your phase, amperage, motor size, frame size, manufacture date, etc. And this is one of the most important parts of your motor whenever you need to perform an upgrade or replace this motor, or if it's a motor that can accept parts, you can utilize this nameplate or data plate in order to obtain that information. Motor housing is extremely important as well. We'll talk a bit about these three different encasements that you see here on the screen. Starting from the left, we have an open drip, and this type of enclosure allows air to flow through the motor. But you also introduce a lot of particulates into that motor system. Your bearings, rotors, windings are open to contaminants that can cause a myriad of issues. These enclosures are resistant to liquids entering the machine from a 0 to 15-degree angle. So if this motor is placed the right way, even if it happens to get some sort of water on it due to its configuration, and depending on the angle at which water is hitting that motor, um, it's resistant to those liquids entering at specific angles. Directly next door to the right, you have a totally enclosed motor, and these motors prevent the free exchange of air between the inside and outside of the frame, but does not make the frame completely airtight. A fan is attached to the shaft and pushes air over the frame during its operation to help and aid in the cooling process. So just like our previous slide where we saw the fan system back here, just a fan blade sitting on the shaft of the rotor, and when this rotor is spinning, your fan back here is spinning as well, drawing in air in order to cool the motor and its windings in a totally enclosed motor system. And then lastly, you have explosion-proof motors. The explosion-proof motor is totally enclosed motor, and it's designed to withstand an explosion of specified gas or vapor inside the site where the motor is operating. And the motor casing, um, the design of the motor casing prevents the ignition outside of the motor by sparks, flashing, or explosion. So the design of this specific explosion-proof motor, its exterior, that casing that you can see around it, is designed to prevent the ignition of any is designed to prevent ignition outside the motor. So anything outside of that motor, meaning the space that it's in, um, could create any type of sparking, flashing, or explosion. This motor won't be subjected to any of the things happening outside of it because of its build and the casing that surrounds it. So if you have like a sort of hazardous environment, such as a chemical plant, the oil industries, gas and wood plastic processing industries, you typically find these explosion-proof type motors. And like I said, any type of arcing or gases that can cause some sort of explosion due to electrical operation, this motor will not be affected by it. So depending upon your application, you want to make sure that one of these housings, motor housings, is specific to the type of application that you'll be running the motor system in. The agriculture industry is another area where your explosion proof type motors operate. And then we did talk about the fan located in this motor. All motors have a fan, and the job of the fan is to move cool air across the motor to help prevent overheating. Oftentimes, the housing will have additional features like fins to help remove heat from the internal components of the motors. So these are the fan that's located back there. It's just blades that move the air, fan blades that move the air. And we saw that it sits in the back of the motor in the housing. Cools the motor during its operation, and it's connected to the opposite end of the shaft. And here we have our rotor and stator. And the most important part of the motor is the rotor and the stator. The rotor is the moving part of the motor, while the stator is the stationary piece. Together, the rotor and the stator do all the work of the motor, and they translate electrical energy into mechanical energy. So here you can see you have your stator, and this is just the stationary part of the motor where all your windings are housed. And then to the right here, you have your rotor, and this is the moving part of the electrical motor. This rotor here is where your shaft is housed as well. And you can see in here you have bearings. A lot of the time you can buy a bearing kit and replace these bearings if you have an issue, if it's applicable to that specific motor. And here we're just going to talk, look at a few different images of types of stators available in motors. Stators can look different depending on the motor type. DC motors or direct current motors have stators composed of stationary magnetic plates, while induction AC motors have stators composed of bundles of copper wiring. So you can see the design across the types of motors, and then within your AC motors, between single and three phase, how the winding configuration is set up. So they're all very different configurations as far as the windings and how they're set up inside of your stators. And your types of rotors. Here we can see a few different types of rotors available for motor systems. And we want to remember that the rotor is the shaft that rotates inside the motor. And there are a number of different types of rotor designs. The most common is the squirrel cage type motor design here. You can see here, found in induction AC motors, but there are a lot of others. These designs range from your wound rotor to your salient pole rotor, and also non-salient rotor. Another important piece of another important component or item associated with your motor system is the nameplate. And the nameplate is extremely important. It can be found on every motor, and it contains all the information about the motor essential for proper installation and function. Now, not all nameplates are organized the same way, but they do contain the same information. So some of that information you may be able to find on a motor or information such as the horsepower, voltage, amps, revolutions per minute, your frame size, efficiency rating, and a few other items. You can find that in the field, you'll find that some motor data plates can get warped, where you're unable to read the information that's located on it. And that's due to environmental conditions and improper maintenance, which leads to corrosion of these data plates. So you want to make sure you're doing your your maintenance in order to maintain these data plates on these motors for the event you need to replace it and need to obtain information in order to do so. So once again, here we have a quick review. So this here of the induction motor and its anatomy. We understand that an electric motor is utilized for converting electrical power into mechanical power. And electric motors generate magnetic fields with electric current through a coil. The magnetic field then causes a force with a magnet that causes movement or spinning, which then runs that motor. Okay, the main parts of the motor, once again, we spoke about the stator, which is the stationary part of the motor where the windings are housed. We spoke about the rotor, the moving part of the electrical motor, and the bearings. The bearings are designed to support the rotor and maintain the correct position of the rotating shaft. Bearings are actually not too hard to replace. I've done a few bearing kit replacements in the field. What's pretty cool about it is instead of replacing a $1,500 motor, you can buy a $150 or $175 bearing kit and replace your failed bearings within that motor system. We touched on the fan, which is stored in the back of the motor housing, and this fan is used to cool the motor during its operation, and it's connected to the opposite end of the shaft, so that way it can rotate and provide cooling, draw in nice cool air from the area it's located in to cool down the motor during its operation. And then we have the motor terminal housing, which is located right up here. And all that is for housing the electrical connection or electrical wiring for connecting power directly to the motor. And lastly, we touched on the nameplate, which declares motor information such as the voltage, phase, amperage, motor size, frame, efficiency, manufacture date, etc. All that information that allows us to verify and make sure that the operation of the motor is to its design, and also if we need to replace that motor in the near future. So that is the anatomy of our induction type motors. We're going to pause here really quickly for some questions, and we're going to hold here as well because we are getting near to our closing time. So let's pause here for some questions, and we will end our broadcast on this note here. But before we do, let's see, Diane, do we have any questions in our chat on what we have covered thus far?
No questions.
Okay, sounds good. Yeah, so what we'll do is I think we're at a good stopping point here in order to continue on for our day 2 presentation of motors and ASDs. We have a small bit more to cover on motor systems, which we will continue on Thursday, and then we'll jump right into our ASD VFD section. So I do want to thank you all for joining us today on our motors and ASDs presentation presented by DNR International. I was your instructor today, Lester Terrance, and I look forward to seeing you this Thursday at our part 2 of motors and ASDs. For everyone who participated, once again, thank you for your active participation, and I look forward to seeing each one of you back here on Thursday. So if we have no more questions, I will turn it back over to our
Katie.
point of contact, Katie, our point of contact. Thank you, Diane. I do appreciate that. So that way we can close out our session today.
Yep. Great. Thank you, Lester. That was an excellent overview. For anybody who's not registered for Thursday's class, go to lightingdesignlab.com where you registered for this first class, and make sure you get signed up so you get the link for Thursday. All right. Thanks, everyone. I'm going to close out the webinar for today.
Awesome. Thank you.
Can you hold on one second?